Perfect. We have lawyers, so safe harbor statement. Want to talk to you a little bit about Intel and our factories and what we're doing in our factories, and then talk a little bit about how we partnered with GE Digital to solve some of the problems we're occurring in our factory. One thing about Intel that's different than most of you, I know Craig said no one goes out and rips out all their old equipment and put new equipment in except our industry. We only get 2 nodes out of a factory. So if you know 14 nanometer, 10 nanometer, we have 14 nanometer running right now in 3 factories. We're qualifying 10 nanometers, and our 7 nanometer factory in Chandler that costs $7 billion is under construction with a whole new set of equipment. So our physical process requires us to do what is unnatural for everybody else. And the reason is that the wires and the electronics we're laying down are 100 atoms in diameter. So we're manufacturing at the atomic level. One thing we had to do at Intel is get every human being out of our factory, because the #1 source of defect of our products, unfortunately, are us. I'm outgassing hair, molecules, skin, all sorts of stuff. Water vapors are coming out of me. If any of that lands on our product won't work. So we have to get as many things out of our factory as possible. So the only people in our factory are doing maintenance. We have no operators in our factory. One of our end factories is monitoring 8 billion endpoints a day. So 8 billion endpoints are sending information into our systems so that we can monitor the data in real time to see what we need to react to. And we're going through over a petabyte of data per plant per day. So when you get to scale, that's where you're going to be. Now, a lot of you are going to say, hey, you're semiconductor, you're totally at the edge of manufacturing where we are. I'm never going to get to that volume of data. And I'm going to remind you that a sensor is an analog thing, and it speaks in hertz. And when you start adding up sensors that speak in hertz, you get to big data very, very quickly. So once we start implementing our plants, we're going to end up with big data. And the question is how do we manage big data? How do we secure big data? How do we get this in our plant and make it work? So we had to do this for our process. So it's not like we figured out IoT in the 80s and said, hey, we're going to be ahead of everybody. Our process forced us to do this. I kind of talked through that. I'm going to be going quickly because of time. This is our architecture of our factory. And one of the key things that most people don't have in their factories, where's the laser? I'll just talk about the middleware cluster. So that desktop client middleware cluster, most people have MES systems, data operating systems, ERP systems in their factory, and all sorts of different factory systems that are running your factory. We also have that. But what we also did is our production equipment, when the co-founder of Intel, Robert Noyce, retired as the first CEO, he became president of the Semico organization, which is our standards group, and we forced the adoption of what OPA is doing today. We did that in the 70s. So the semiconductor industry already has a semiconductor equipment communication standard / generic equipment model. We've been running for 30 years. We get equipment, we plug it in, we get all the data off it. So we've already figured that out in the semiconductor industry. So we'll put a desktop client, it's a Core i7 running 0.5 terabyte of SSDs, beside every piece of equipment to take all the data off of the equipment and run advanced analytics. We have machine learning analytics running our process in real time, and the inference engines are running on that desktop right there. So we train our models up in the cloud or up in the high-performance compute area, which for us are our data centers. And when we get the models, we drop them down to our edge and run the models on the edge. The reason we do that is real simple. If we were to take all that production data, a petabyte of data a day, and punch it up to the cloud, do you know how big that network is? So we bring the cloud to the data. When you're deciding where compute is, this whole thing about edge and fog is just marketing. Forget it. It doesn't mean anything. Seriously, it means nothing. What we have is compute and data. If you want to do anything in the digital world, the two have to come together. That's called a network. So you can either take your data to your compute through the network, or you can take your computer to the data. So what we did at Intel is we went to our data center, we took some blades out of our data center and stuck it where the data was, which is right beside the production equipment. And the computer didn't get lonely. And it just sits right by the equipment, and we manage it as a distributed compute network. So it's all one compute, and we can orchestrate it from the edge to our data centers at our factory and move workloads in real time around. And we have a demo of that running, or had a demo in the booth earlier, you could have seen something like that. So this is what we're running and how we're running it. What I'm going to talk about is that gateway, down on that little loop here. This guy right here. I'll talk about that gateway, because our edge compute here is really designed to work with the production equipment. It's really tuned to the production equipment. But let's say, hey, we're not getting everything we need to do more. How do we do that? We use those gateways to do that. So let me keep going for time and get into this story. So as I said, number one source of defects in our product are particles. Particles coming off of people. We actually have atoms outgassing off of metal in our tools that fall on our product and cause defects. So in our tools, we have to suck a vacuum to keep our product in a vacuum so that we can manufacture it. So we have lots of fans pulling that vacuum on our equipment. And unfortunately, those fans didn't have sensors on them when we got it from our equipment vendors. And a cause of failure would be these fans failing. We don't know they failed. And then we're producing stuff. And then when we get later, after producing 25 wafers, we get to the inspection step and we look at it and we see all that stuff on the right on our product and it doesn't work. And this is very expensive for us because we produce batches. We have a batch of 25 wafers. We do it once, 300 millimeter wafers. And these things are worth millions of dollars, depending on where they are in the process. So this comes very, very expensive. So big issue, let's go solve this. How do we figure out how to solve this? So here's our production equipment. I'll walk around so you can see it. These are old pictures. We don't have pictures of people on the so this is a fan right here pulling out the air so we can run a vacuum. This is 20 years old. Those are 6-inch wafers. We don't have people in our fabs. We have to use old pictures to show things, sorry. But what must we have? So have to understand a hard failure. I need to know within a very short period of time if something stops working now to a very high degree of probability. And then if it's a soft failure, meaning it's going to fail in the future, I'm predicting failure, I have to have that within a reasonable accuracy as well. So what we said is we need to be able to detect 80% of our soft failures within 24 and all of our hard failures within 5 minutes. So these were our design criteria. So we set design criteria. Nice to have, well, we had some other stuff, 10 hertz. We'd like to use smaller sensors because the bigger the sensor, the more network you have to push through, all that kind of stuff. Love to support mobile apps so people could walk around and look at what it's doing. But these are the must-haves. We actually have to have this engineering. So what we did is we partnered with GE. And this, from a business perspective, the hardest thing in this partnership was to agree to partner. Before this, Intel was doing all this by ourselves. We don't have systems integrators. Our IT department and our OT department were integrated 30 years ago, so they report to the same management structure. So how do you put them together? You put them together. It's not hard. We have data scientists and process engineers in IT. If data is the new gold, IT is strategic. How many people here is IT strategic in your company? Show a hand. It is for us. If it's the new gold, shouldn't you be doing something other than a cost center about it? It's a profit center. So our IT group is challenged with going out. So I have a buddy, Steve Chadwick. Let me step back. McKinsey did a study about 2 years ago. And in that study, they said, if you're a big manufacturer, IoT can save you billions. If you got a big supply chain, you can save hundreds of millions. If you have a lot of buildings, you can save tens of millions. So unfortunately, our management read that. They went to us and said, hey, billion, 100 million, tens of million, here are your KPIs. So Steve has a KPI of finding $500 million worth of savings by 2020, and he's going to beat it. He's got a roadmap to beat it. So we're taking this seriously and driving this, and engineers have KPIs to go make this stuff work. So what did we do? We need to continuously monitor. We're a 24/365, you don't shut down a semiconductor factory. Just like an oil refinery, don't turn it off. It's hard to turn back on. So we took these sensors, we put them on the fans, connecting them to a gateway. Now the gateway, here's something about Intel. We manage that gateway ourselves. We could manage that gateway through Predix. But because we're Intel, we're going to do all the device management ourselves. It's too strategic not to. So to allow the data to leave our factory, to go to Predix, required the permission of our CEO. It literally had to go to our CEO. It was the first time we ever took production data and let it go, because our production data is our IP. If you saw our production data, you could build what we build, and that we can't let happen. So it's incredibly valuable to us. It is everything to us. So a lot of contracts, a lot of lawyers, we put it together and started to work together with GE. So we put this together, we trained the models up in Predix, so we used the Predix stuff, trained the models, got our algorithms, dropped them back down to the gateway to run on the gateway. And then what we're doing is we're punching enough data up to Predix so it can watch, is this thing moving? The issue with machine learning, when you're using machine learning, and we just talked about this drift. Machine learning can drift, and machine learning doesn't notice drift very well. So you have to have other models watching that model. And so we'll do that up in Predix, where we're up in Predix watching what we're doing on the edge and correcting it and setting new algorithms down when we recorrect it. So we're always recorrecting as we learn and moving it. So we're using the two back and forth. Here's the architecture. So we took our gateway. It's an Advantech. It could be anything. It's just an x86 based gateway. We're doing the device management, so we put a Predix box on it. Our strategy, when I showed you that desktop client, we've virtualized that. So I can orchestrate across workloads and move different things around. This gateway wasn't virtualized, but in the future it will be. We'll be doing the same thing with those as well. And as you can see, we're moving over into the cloud. That's Predix. And how we're working with clouds, the historians over there, the analytics UI, all the monitoring, and all that comes through. The Python scripting, that's the inference engine. That's what's running on the edge. Sorry, I'm trying to keep track of my time. All right, we're getting close. Data explosion. So we piloted with one gateway, then we put 15 in, and then 300 in, and you can see the network, what this does. So data explodes, especially when you're using analog sensors, because analog sensors speak hertz, kilohertz, and it's just big. So understanding how you can build your networks, I don't have time here to talk about how we isolate our networks, but when WannaCry hit, you guys probably remember WannaCry, we were offline in what we call armadillo mode within 3 minutes. So we had the ability to sense that there was something new out in the internet, and we can isolate our factory so that nothing can talk to it, and only the factory will talk to itself to isolate it. And in 3 days, we didn't let them go, and we finally figured out what it was, how to fix, and then brought them back online. So in those 3 days, I couldn't roll up all the different factories and say, how's factory X doing to factory Y? But factory X and Y ran, and ran well, and could keep moving even though we had to isolate them. So we've spent a lot of effort, and I can show you what we did on that. Don't have time. I only have a minute and a half left. We're rolling it out. One thing that's impressive about Intel is when we get a solution at one spot, it goes to every factory that's building that process. And it goes there within 24 hours. So to change our process, you have to go to a review board. The review board approves it. Every other factory making that product has 24 hours to do that upgrade, or they have to explain why. Now, they might have to order equipment. There could be reasons that you can't do it, but to minimize variation in our manufacturing process, that's what we do. We have to have that level. So how do you scale? You solve it once, you should be solving it everywhere. So how do you roll it out? Come talk to me. We got stuff on the internet. Love to show you what we're doing. We're willing to benchmark what we've been doing. And the business reason we're willing to do it, if data moves, somebody's using Intel. So, it's in our best interest for you guys to succeed. And the faster you guys succeed, the more we sell. So we are very motivated for your success. So anything we can do to help you, let me know. Thank you. Oh, one last comment. Craig mentions those recordings, those chart recordings and gauges. There's a really cool, inexpensive machine vision solution to digitize. You just put a small camera right there at reading it, and you can digitize the signal and send it back. It's now in the market. It's cheap. We have that as well. We don't sell it, but our partners sell it. Cheers.